Okay, let's try to quickly make a double pendulum. We'll start with Blender, and we'll create a single pendulum to begin with. So we have this. We're going to duplicate it, grab it, move it in the Z direction, -4. Let's look at it from the side here. There we go. So this will make it into a clamp. Joint, clamp, boom, there we go. And this will make it into a body. Boom, body. Okay, there we go. And you'll notice as we scroll through this from clamp to body, we highlight the item. And that's true of all elements. So next we'll make a distance joint here. It doesn't matter which way we go, but I kind of prefer to go that way. So we'll make a joint, distance joint from the nodes. Okay, that's good. Need to add gravity. So we'll add environment, gravity. It'll be, we'll take this vector and we'll scale it by 9.8. And then one other item, we need to force this. So we'll take this item, the mass, and we'll add a force to it, structural force, be a follower, unit drive initially, fine, and we have to rotate X, no, Y, all right, good. So we're rotating it, and this pyramid, that points in the direction of the Z-axis of the body, which is the direction we always use for a force. So with that, we should be good to go. We'll create a simulation, and we need to save the Blender file. There we go. Run the simulation. Animate the objects. We'll take about every 100th object or so, or 100th time step for about 100 steps, and boom, there we go. So, all right. And just want to make sure, I believe that's fine. If I look at my, oh, I didn't give gravity a direction. Gravity in the -1, okay, that's better. Now that should look right. So if we go in and reanimate this, and then, all right, now this should work a little better. There we go. We've got that force going and gravity holding it back. So that's what we want. Now, I'll increase the force, and the way to do that is to add a drive. This time we'll do a constant drive. Let's make it a constant of 5. Let's see here. Oh, there we go. And with that, we go up to our structural force over here, edit that, and change the from unit drive to that constant drive. We'll click this and we'll see that, yep, that's what we got. Now if we reanimate this, okay, what we'll see is it'll move further. There we go, but it's constant. Next, we want that just to be a force for a short period of time. So we'll add a, let's call this we'll make that a driven element. And so we're going to make the structural force a driven element, but we don't want to drive it the whole time. We only want to drive it for a short period of time. So we'll create a new drive. We'll call this a string drive. And we'll apply this for the first second. So time less than 1.0. All right, that's our string drive. We go back up to our driven, edit that, change it from the unit drive to now the string drive. And when we animate, what we'll see is, okay, we'll start it moving, and then it'll just rock back and forth. Perfect. Okay, so that's our pendulum. Now what we want to do is make a double pendulum. So we'll take these two and come here and duplicate. Okay, grab this, move it in the Z direction -3. Now what we can see is we have both pendulums. if we simulate this, it'll behave as you might expect. Says you have two pendulums, each pin, and they move in parallel. Now what we'll do is take this second pendulum here, and we'll use this distance joint. Where is that distance joint? Right here. Okay, so that distance joint goes here. This is one of those nodes, and that is cube 3. And we want to instead have it be at cube 1 so that this will be a double pendulum. So we'll take this distance joint and reassign the nodes. The node that's cube 3 will make that cube 1. Okay? And now, if we go through, let me see, this is a clamp. If we get rid of that clamp, let's see here, where is that? There we go, that clamp. If we get rid of that clamp, now if we go through our list of elements, you'll notice that this item here is never highlighted because it's not part of any element. We've got our clamp at the top, we have our body, our distance joint, our this is, well, gravity now. That's the force on the first body. That's the driven. That's the mass on the second body. And so that's it, right? So we've got, oh wait, let's see, we're going further down. We've got our distance joint and structural force, and that's driven. All right, so this no longer is part of the model, but we'll keep it there anyway. So now, redo the simulation, run the simulation, and if all went well, we'll have our double pendulum. There we go. Right. And you can look at it from whatever direction you want. Okay, good. Hope you enjoyed that.